Alright, welcome. In this video, I'm going to be working 2024 Calculus AB free response question 5, the implicit derivative question. So consider the curve defined by this implicit equation here, and it can be shown that dy dx equals that fraction. Alright, there's a point on the curve near x equals 2 and y equals 4 with x coordinate 3. Use the line tangent to the curve at x equals 2 and y equals 4 to approximate the y coordinate of this point. That's an interesting one. Okay, so we've got a point. We're going to need a slope, and then we'll write an equation and get an approximation. So the point is going to be x equals 2, y equals 4. The slope is going to be, okay, dy dx at the point 2, 4 is going to be negative 2 times 2 is negative 4, divided by 3 plus 4y. 3 plus 16 equals 19. Okay, that's an interesting slope. My equation is going to be y minus 4 equals negative 4 over 19 times x minus 2. And then my approximation, which I'll write down after that, is going to be y is approximately equal to 4 minus 4 over 19, because I've added the 4 to both sides, plugging in x equals 3, and, because this is AP Calculus, we don't have to simplify our answer. We're going to stop right there. We're going to be satisfied with that approximation. Is the horizontal line y equals 1 tangent to the curve? Okay, well, we're going to be interested to see if whenever y equals 1, is dy dx going to equal 0? Okay, so let's investigate what happens when y equals 1. So if y equals 1, I'm going to go back to the original equation. X squared plus 3 plus 2 times y squared would just be plus a 2 is going to equal 48. Okay, so that would be x squared plus 5 equals 48. X squared equals 43. Okay, that's going to be x equaling 1 tangent to the curve. X equals plus or minus the square root of 43. Okay, it's the horizontal line, y equals 1 tangent to the curve. Yeah, so 3 plus 2 is 5. This just seems wrong, right? X squared plus 5 equals 48. Any point on the curve where y equals 1 must have x equaling one of those two x values. And then dy dx is not going to equal 0, so no. Okay. Non-zero derivative. A horizontal line cannot be tangent to the curve. Maybe at x equals, or maybe at square root 43, 0. Nope, not 0. It was y equaling 1. And negative square root of 43 comma 1. Okay, that was a weird one. Okay, part C. The curve intersects the positive x-axis at the point where x is the square root of 48 and the y is 0. Okay, is the line tangent to the curve at this point vertical? Give a reason for your answer. Thinking back to last year, I'm hopeful that this one's yes, because I remember kind of something like this last year where it was like one yes and one no. So let's think about dy dx at the point where x equals square root 48 and y equals 0. That's going to equal negative 2 times x divided by 3 plus 4y. And this is equal to, I don't need to simplify it. it could definitely be simplified because 48's got the factor of 16 in it. And I would say because this value exists at the point square root of 48 and 0, the tangent line cannot be vertical. I was kind of hopeful that we'd have a no and a yes, but I think we would need x equaling 0 for a horizontal line to be for the tangent line to be horizontal, and we would need y equaling -3/4 in order for a tangent line to be vertical. Okay, now part D is going to be asking me about a different curve. Okay, yeah, this has nothing to do with the previous parts, so I'm just going to clear up my writing. And, okay, I'm seeing what they're doing here. They're doing the same thing they did last year in 2023. They're going to have an object moving around along the curve, and we're going to take the derivative with respect to time, and it's going to be kind of like a related rate question. Okay, so we've got y cubed plus 2xy equals 24, and we're going to take the derivative of both sides with respect to time. So with respect to time, the derivative of y cubed is going to be 3y squared times dy dt for the chain rule. Then I'm going to take the derivative of 2x, because I'm going to have to use the product rule, so 2 dx dt, leave y the same, then leave 2x the same, and take the derivative of y with respect to time, and then that'll equal the derivative of 24 with respect to time, which is going to equal 0. Okay, at the instant the particle is at the point 4 and 2, so I'm going to plug in x equals 4 and y equals 2. 2, we don't know dx dt yet, y was equal to 2, 4, and then, one of these they're going to give us and the other one we will find, but, we're going to have an equation that's very solvable based on what I'm looking at here. Okay, the y coordinate is decreasing by 2 per second, so dy dt is -2. So I'm going to have this equaling -2 and that one equaling -2. So -24 plus 4 times the thing I'm hoping to solve for, dx dt, plus or minus 4 times 4 is 16, that's going to equal 0. Okay, so 24 and 16 is going to be 40. Okay, I'm going to solve for dx dt by adding 40 to both sides, and then dividing by 4. And then, at that instant, what's the rate of change of the x-coordinate? That's dx dt, that's equaling 10, great. It didn't say to indicate units of measure because it's just going to be also units per second. That's not all that more interesting than what they already told us. Okay, so that's it. That is free response question 5 for Calculus AB solved. Okay, so that's all for this video. Thanks for watching.